Hello guys, in this video we will solve diabetes prediction classification problem. Uh, in We have provided dataset name is diabetes prediction dataset. It has around you can say 9 columns. One is gender, age, hypertension, heart disease, smoking history, BMI, HbAI, A1C level, blood glucose level, and diabetes. Here our target variable is diabetes. It has if it has he or she has diabetes, then it will be 1, and if he do not have diabetes, it will be 0. So let me do one thing, give you overview what we have to do. First we will import our CSV file. Then what we have to clean our file. Clean our file. Here we will do drop duplicates value, duplicates value, drop duplicate values, and if there is any null value, we will fill it with we will try to fill it. So say handle null values. After that we will do visualization. Then we will start our training part. For training, first we have to we split our data into independent variable, independent and dependent variable. And after that, if there is any scaling needed or normalization needed, then we do this. You can say standardization. And after that, before standardization, we have to do one more thing, that is split data into training and testing set. After standardization, what we have to do, we will train our model, and after training we will hypertune it. Hyperparameter tuning, and at the end we will save our model, and then deploy our, or you can say create our web app, create our Flask web app. Cool. So let me open my notebook. So initially we imported our necessary libraries, like what libraries we required in this analysis, or you can say in this project. We need NumPy, Pandas, Matplotlib, Seaborn, scikit-learn libraries, and here it is. We need Smart also, and PC also. I will explain you later what is Smart and what is PCA. So start initially we imported our CSV file using using our method pd.read CSV and save it in df data frame. So we do df.head. Let me start running this. Here we get the this. Then we check what's the shape. So this is giving me, it has you can say 10,000 sorry 1 lakh rows and 9 columns. And now we are checking for if there is any null values or not. We can see there is no null values. So if there, now we are checking if there is any duplicate value counts. So for that we are using df dot duplicated. Let me do one thing. If we just use df dot duplicated, it will give me value in true and false. If it is duplicated, then it will give me true, and if the value is not duplicated, or you can say unique, then it will give me false. So for counting the sum, we have to use sum method also. Here you can see these values are duplicated. 3854 values are duplicates. So now we will try to remove this duplicate value. For that we have a function called df.drop duplicate, and I am using in place is equal to true. In place is equal to true means I am saving this. Let me do one thing. If I will just use df.drop duplicates and run this command, this will give me data frame, but this data frame is different from df. You can say df, let me here you can say df.shape, and this data frame is not saved yet. So if I have to save this data frame in my df data frame, then I have to use in place is equal to true. This will you can say rewrite my df data frame. So it remove it dropped my duplicate value. Let me now see df.shape. Here you can see my duplicate values are removed. Now we are seeing what are column name in our data frame. Here you can see we have gender, age, hypertension, heart disease, smoking history, BMI, HbA1c level, blood glucose level, and diabetes. Now let me do one more thing. Let me see more info about my data frame. Here you can see there is some data type with there are some columns with object data type like gender and smoking history. Just there is two. So also we have integer value like hypertension and heart disease. So now what we are doing, we take this column like gender and hypertension, heart disease, smoking history, and you can say diabetes, and find unique values in these given columns. So we define our columns. Columns is equal to list. In list we have elements called gender, hypertension, heart disease, smoking history, and diabetes. And we run a for loop for call in columns. We print call means our column name, comma, df of call dot unique means unique values uh, uh, in our column, in our data frame. So we are getting in gender we have male, female, and other. And in hypertension we have just two numeric values, that is 0 and 1. In heart disease we have similarly two unique values, uh, one is 0 and another one is 1. And in our smoking history we have many unique values. We have never, we have no info, we have current, we have former, we have ever, we have not current. And in our diabetes column we have two unique values, one is 0 and one is 1. Here, zero means that our patient has not diabetes, and one means yes, our patient is diabetic. So now what we do, we are trying to check what's the value count in what's the how many rows have gender is equal to other. Now we are checking it using. So if we use this command, we get you can say false, where our gender is other. It will say here at that place it will say it is true, and else it will say false. So now I am trying to uh, check my rows. You can say I want to see rows which has gender is equal to other. Let me run this command. Hey, I got gender is equal to other, and here age is hypertension, my complete data set. So now I want to see how many entries or rows are this. For that I have to use dot shape. So we have 18 you can say 18 rows. Similarly, I'm doing this for my smoking history. How many columns have no, oh, sorry, in smoking history, how many rows have no info? So it is around 32,887. Similarly, for note current, we have 6,000, around 6,000, and for former, we have around 10,000. We can use df.summary for summarizing our data, for summarizing our numerical data, like age is in numerical, you can say age is in numerical value, hypertension is also in numeric value, it is in like 0 and 1. Similarly, heart disease also in numeric value, which is 0 and 1, and in BMI it is in float value. HbA1c level is also in float value. Blood glucose level also was in our float value. So now we can see here our standard. We can see mean value for every column. We can see standard deviation. We can say minimum value. We can also say 25 percentile. We can also say 50 percentile, or we can say it is our median value, and 75 percentile and maximum value. Like our maximum value for blood glucose level is around 300. Now if you can see our this part is done. Let me write, yes, we imported our CSV file, we dropped the duplicate value, yes, and yes, we handled our null, there is no null values. So we done this. Now we have to visualize our data. For that, uh, I'll I will create a count plot of smoking history. Here you can see I am getting a graph of count of individuals by smoking history. We can see there is a high level of count of never smoked a cigarette, or you can say anything, and we can also see there is huge value of no information. It means we do not have data for this. Now what we are doing, we are creating a count of individuals by smoking history and uh, diabetes status. Now we are filtering, or you can say creating a hui for who has diabetes and who do not have diabetes. For that we will do one thing. Here we can also use hui, but I use, let me check. So we created, you can say we have 6 unique values. So now we created 12 new data frames. In every data frame we have, like in never one we have data where smoking history is never and diabetes value is 1. Similarly for never 0 we have smoking history is never and diabetes value is 0. Let me do one thing. let oh, Let me show you. Here you can see our diabetes value is 1 and smoking history is never. So now we are saving this in a variable called never1. Here you can see we are saving this in never1. Similarly for never 0 we means it means smoking history is never and diabetes value is 0. For no info our smoking history is no info and diabetes value is 1. And for no info 0 smoking history is no info and diabetes value is 0. For current one it means smoking history is current and diabetes value is 1. Similarly like that we created 12 different you can say data frames. Now we are combining this complete data, or you can say concatenating this complete data. For that we use smoking history df is equal to pd dot concatenate and uh, give this old data frame in a list format and then create a histogram on a basis of or sorry or we created a histogram using our Seaborn library. Seaborn we save it as here you can see I imported my Seaborn as SNS. So from as Seaborn I used count plot function where my x value is my data is smoking history data frame which I defined it here and x value is smoking history and my hue, or you can say how I have to split it using diabetes. So or you can say how I have to filter, I have to filter using diabetes. So I give here x label. X label is my smoking history. Similarly, y label is my count of individuals, and here I define the title and give plt dot legends. Legends is my title is equal to diabetes. Here I for this code is for this part. Here you can see my title is diabetes, and for first label I give without diabetes, and for second we have with diabetes. We type plt dot show. Let me run this. Yes, we get our visualization. Here you can see we will see there is a similar kind of trend as in our previous visualization. So now we are similarly doing gender distribution. In gender distribution we created the similar you can say histogram. Here you can see we have more values of females in our data set as compared to male, and there is negligible value for other. Similarly we do this for we filter you can say filter this for our it has diabetes or not diabetic. uh, I think I do not need to explain this part because this is similar as this one. Just we you can say change it change there is just slightly change between this x part. Instead of here smoking history we have gender, and in this data frame instead of gender instead of smoking history we have gender. So now we draw a distribution. Here we take our bin size as 10. So it is our complete distribution is split into 10 different bins. Also then we distribute created a box plot and shorted using you can say filter using diabetes. If you can see here uh, in this visualization we can see a person who have diabetes are more uh, elder, you can say elder than person who do not have diabetes. From this relation we can see. Then we do for hypertension, this we created hypertension distribution using using same commands. I think it you can understand this command easily, because this is same as this is same as this one and this one. Then we created same for heart disease distribution. Then we created a box plot for BMI. Here you can see there is a high BMI of a patient who has diabetes and who has diabetes as compared to person who do not have diabetes. Here we can also see a rise in HbA1c level also, and also blood glucose level. Now we created correlation heat map. In this, for correlation, there is a condition that our data frame should have numeric values, or you can say numeric columns. So we selected just columns which has numeric data type, uh, or you can say it can be of integer or it can be of float. So we selected that column and used our method dot core. Dot core is for finding correlation, and then save this in a core variable. Then for creating this heat map, we use sns dot heat map. Our data is core, and type annotation is equal to true. For not equal to true, we get our values here. If we use this as false, then we do not get these values. Here you can see. So but we need this value, that's why we give this as true. And cmap cool warm is nothing but this is for color palette. Let me, here you can see the color is changed. This is just for color. Okay, I give the title here correlation heat map. Here you can see plt dot show. Okay, now our visualization is also done. Now here we come one hot encoding. Yes, uh, if you know, our model take just numeric values, so that's why we have, we can say 3 or we can say 4a. So we have to convert categorical categorical variables into numerical numeric data type, into numeric variables, or we can say, because our model just take numeric values. So for that, if you can see, our complete data is in numeric type. Here you can see, here you can see our complete data. This column also has, this column has numeric variable. It has numeric value. BMI has numeric value. The HbA1c value has numeric value. All these have numeric value. Just two columns, one is gender and one is smoking history. These have categorical value, so we are performing one hot encoding for these two columns. Let me go to, here we can see, now doing one hot encoding of gender and smoking history column. So for doing one hot encoding, we used pd dot get dummies, and let me do it for just this time for one column, like gender, and let me run this. Here you can see I got my values in true and false. If I have to get my values uh, int of, you can say, 1 in 0, then I have to type as int. Now I am getting values in 1 and 0. So if you can see, we get three different columns. One is male, female, and other. But if you can see, I can define this other value using just these two variables. Let me show you how I am giving this. Let's say we have male, female, and other. Let's assume our first value is male. So I will give 1 for male, 0 for female, and 0 for other. But and now assume our value is for female. Our value is female. Then for male it is 0, for female it is 1, and for other it will 0. But let's assume if our value is other, then it will say male as female, male and female as 0 and other as 1. But if we remove these values, here we can also say for male and female for both 0, this means our other value is 1 here. That's why we can drop this column. That's why I use drop comma drop equal drop first is equal to true. If we type here drop first is equal to true, it will drop our first column. Here you can see. Similarly, here I do for two columns. Here for gender and smoking history. Here you can see. Then I concatenating one hot encoding columns with other numeric columns. Here it must be other numeric columns. My other numeric columns are age, hypertension, heart disease, BMI, HB, A1C level, blood glucose level. And I save this one hot encoding into dummy underscore df variable. So I use this dummy underscore df. And for concatenating, we use df dot concat function. Then we have to give this our data in a list format, which data frame we want to you can say concatenate. Like our first data frame is this. Let me copy this, and our second data frame is this dummy df. Okay, we paste it here. Now we have to give the axis how we want to concatenate. So we want to concatenate in form of you can say we want to add new columns, not new rows. That's why we use x is equal to 1, and we save this into a x variable. So here you can see we get our x. Or you can say x is our independent variable. These all are independent variable, or you can say our features. And yes, here I defined my y, which is my feature. Not feature, it is our target variable. So let me see. Let me delete this. Here you can see this part is done. One hot encoding is done. We split our data into independent variables. This is also done. Now we have to use standardization. Let's see. For scaling, we have two methods. One is min-max scaler and another is standard scaler. Let me show you difference between standard scaler and or you can say standard scaler and min-max scaler. Min-max scaler, what it do in min-max scaler, we convert our data into, or you can say we transform our data into 0 to 1, and for this formula is x of like let me see, x minus x of mean, or you can say x of minimum divided by, how can I write divide here, or we can x minus x minimum divided by x maximum minus x minimum. For min-max scale, we use this formula, but in standard scaler, we transform our data in you can say normal distribution, or you can say in Gauss normal distribution. In this, our mean value is equal to 0 and standard deviation is equal to 1. And for this we have a formula that is x minus x mean divided by standard deviation of, let me check it, standard scalar formula. Here is x minus mean divided by standard deviation, so we have to divide this by standard deviation. Okay, so but in this case we are using min-max scaler. Here we scaled our here we defined our you can say min-max scaler in a scalar variable, and then we use scalar dot fit transform into x, and then we save this x into x variable. Here you can see my value is transformed from 0 to 1. Here you can see this is between 0 to 1, this is also in 0 to 1, this is also between 0 to 1. So now we are saying this is classification problem, that's why we are now checking what's the value count of both the categories. Like for 0 we have 87,664 values, but for 1 we have just 8,084 values. So we can see our data set is highly imbalanced. So for that we will use smart. This smart will do, smart will create dummy values, or you can say similar kind of values for this you can say for this category. Let me initiate smart is equal to smart. Here I am giving my strategy as minority, because I have to fix this value or you can say I want to upscale my data. So I have to create this column as equal to this. For that I use this minority. Then I give value here x. Here I defined x comma y is equal to smart dot fit resample. This will create dummy variables, not dummy variables, dummy entries for my this data set. Here you can see I use y dot value counts, and here you can see I got similar values as 0. Now I defined multiple, you can say multiple algorithms and with their hyperparameter for checking which will be best parameter algorithm with best parameter, or you can say hyperparameter for my algorithm. So here I defined multiple regression classification problem. Sorry, this is a classification problem. That's why we defined all possible classification algorithms like logistic regression, SVC, decision tree classifier, random forest classifier, EDA boost classifier, gradient boosting classifier, Bayesian classifier, Gaussian NB, multinomial NB. Here NB means naive. Now we are training all algorithms and finding best parameter and saving model score in scores. So I initialize a empty list called scores, and then CV is equal to shuffle split. This will split my data set into 5 splits. That is, n splits is equal to 5. Test size will be 0.2 and random set will be 10. Okay. And now we are creating a you can say, now we're running a loop, or you can say for loop, where algo name comma mp in algos road items. So algo name will be this and mp will be our this value, or you can say hyperparameters. Okay. So we are using grid search CV for this. Reg is equal to grid search CV mp of model name, mp of parameters, and CV is equal to this cross validation. Okay, and return train score as false. Here we trained our model, and then we append what data in scores. We append model name, we append best score. The best score we get using this, or you can say this algorithm, and best parameter, which best parameter give us maximum score. Then for visualization we created this we converted this list into a data frame. For this we defined a new data frame called score. Score is equal to pd dot data frame, and our data will be scores, this list, and column name will be model, best score, and best parents. Here you can see we get our value. This is our model name, this is our possible best score, and this is our parameter. Here you can see this empty dictionary means this gave best value for default parameters. Here you can see we get maximum score for which we get maximum score for Bayesian classifier. Here you can see, or 97. Yes, we get maximum score for Bayesian classifier. You can see this, and this algorithm is around similar, giving a similar score. Now we get which algorithm we have to choose. Like I want to train using this random forest classifier. Then I am training my for saving my model. I am again training this. I will again training this. You can say my model using these hyperparameters. Okay, so for that I converted my data into x test and splitted my x and y. Here you can see. Now our aim is to split data into training and testing set. So we splitted our data into xtend and xtest. Then we will train our model using we use algorithm random forest classifier with the hyperparameters and estimator as 100 and criteria as entropy. Here if it using xtrain and xtest, we get our accuracy score as for finding accuracy score. We use model dot score x test comma y test. What it will do, it will do one thing. First it will predict predict values of values for x test using using which thing using our model which we have trained. And after that what it will do, it will compare these values with y test, and then we get our this score. Here we can see we getting 97% accuracy. So now what's our aim? We are trying to create a confusion matrix because here you can see if our data set is imbalanced, so we cannot give a conclusion that yes, this score is if this score is you can say higher, then our model is good or not. For that we have to see recall and precision and F1 score. Let's see for confusion matrix we use y, we predicted for x validation and saved it in ypred and then created confusion matrix. And for confusion matrix we have to sk from scikit-learn dot I think matrices, yes, matrices import matrix import confusion matrix. Confusion, yes, it is in confusion. And also we want to you can say create classification report. Classification, here you can see classification report also in this you can say uh, uh, this module. So we initialize our confusion matrix. For confusion matrix we have two variables. First we have to give ypred y true and then ypred and save this in the cm variable. Then created a heat map for this. Here you can see we created confusion matrix. Then we printed our classification report. In classification report we can see we getting precision value as 0.97 and recall value as 0.97 and our F1 score is 0.97. uh, you can comment down if you want to if you want to get video on what is precision, what is recall, and what is F1 score. Here now what we do, we can see we getting a good accuracy. Now we want to you can say reduce our dimensions of this for this model. So what we have to, we use PCA, that is principal component analysis, and we initialize this PCA comma 0.95. Like I I want to just take my 95% of you can say features or independent variables. Like in my model Let me type it here. In my, let's assume, let's assume in my model, if I if I have 20 variables, or you can say 20 features, and I want to take you can say 0.8 uh, 8, or you can say 80% features, and want to drop 20% features. So we get from from 20 features we get only 16 features. Here we use, instead of 0.8 we use 95, means I want to drop 5% features. Then I use fit underscore transform, and then check the shape. Here you can see my column shape, or you can say my x shape is converted into 10, and then I check, then I use train test split for training and splitting my data into training and testing set, and then fit my model for x train and x test, and try to predict score for x test and y test. Here you can see I am getting 94.7% accuracy, and my precision value is and recall value is also dropped, but my number of features is now decreased. Now what we do, so we trained for random forest classifier, and for random forest classifier we do not need any scaling, we do not need any kind of scaling, because in random forest classifier we create decision tree. In decision tree there is only if else condition, no you can say not high mathematical calculation we have to make. We have to just create decision tree. That's why we do not need scaling for this. So we trained our model. Now for creating web app, we have to uh, save our model. For saving our model, we used, first we have to import pickle, and then we have to use with open model how I want to save my uh, in which file I want to save my model. Like in this case I want to save my model as model.pickle, wb as f, and pickle dot dump, which I have to dump what thing, I have to dump model comma f. So if I run this command I will get model.pickle here. Okay, so now we have trained our model, we hypertune our model, and we have already done this. This part is also done. This is also done. We also saved our model. Now our aim is to create our Flask web app. Let me show you what I want to create. So I want to create this. I want to I want age value. I want to options for gender, hypertension, heart disease, BMI, HbA1c level, blood glucose level, and smoking history. And then I will click on submit. Then if it will predict yes, if it is true, or you can say 1, then it will show me this that we get to inform you that you have diagnosed with diabetes. Please contact your health provider. And if I go to the value as 0, then it will redirect to this page. Yeah, you do not have diabetes. Thanks. That's fantastic news for your health. And we have to add a home button also. So let me do one thing. Open my Flask app and for creating front end, we have to use a we have to uh, uh, give my HTML values to this templates director, or you can say save my HTML values to this templates director. Let me also index.html is my home page. So this is for just beautification, or you can say styling. Here I gave title diagnostics, and here I gave age value. Age value is our number. Gender has three options. One is male, female. One is male, and for male we have value male. For female we have value female. For other we are getting value as other. Similarly, for hypertension, we give two options yes and no. For heart disease, we give two options yes and no. For BMI, it is a float value, so we are now initializing it as text. But when we use this in or you can say load this in our web app, or you can say Python node in our Flask web app, we will convert this into a float value. Similarly, we get for HbA1c level and for blood glucose level. For smoking history, we give around six different options. That is for current, never, ever, former, not current, no info. Then we give a input as a, you can say, submit button also. Now let me come back to our Flask app. So first we defined from Flask. First we imported our Flask. In Flask we need Flask module. We need render template. Render template is for rendering these templates, and for request is to for get these values from, or you can say load these values from HTML. Redirect for redirect is to is used for redirecting to different URLs, and URL for is not, I think, not needed here. We can remove this. Then typed import requests, and then imported pickle. Pickle is for using our this model, because this model is saved in pickle format. So we initialize our app is equal to Flask underscore underscore name underscore underscore, and for this initialization we have to do one more thing. If underscore underscore name is equal underscore underscore is equal to main, then we have to what we have to do, we have to do app dot run. You can ignore this part, because this part is for when we are deploying it on you can say any web server, but you can use debug is equal to true. But this is used for debugging our web app. Like if we get any error, we can change it here, and when we when we save this file, then we get our changes on our local host where our web app is running. Now we load our model. Here we created a app dot route for for what we route for home. Defined a home function. Here return our template index.html, and here you get. I will come back here later. Now, if you see here, here you can see we have a submit button. So when this submit button is hit, it will trigger this part. Here you can see under submit methods post get. We defined this part. We get our value here. We defined, or you can say we load our age value here, hypertension value here, and if our hypertension is equal to no, then we are converting our hypertension value as 0, and if it is yes, then in else condition it will be hypertension is equal to 1. Similarly for heart disease, if our heart disease is equal to no, then it will save heart disease equal to 0. If it is yes, then it will save it as 1. We convert, as we can see here, our BMI is in text format, so that's why we converted this into a float value and loaded here. Similarly, we loaded HbA1c level, then imported blood glucose level. Similarly, we created if-else condition for gender. Like if our gender is equal to male, it will be male is equal to 1 and other is equal to 0. If then we created elif. If our gender is female, then male is equal to 0 and other is equal to 0. If our you can say gender is equal to other, then in else condition we will what we get, male is equal to 0 and other is equal to 1. Similarly, we do this. You can say this is a kind of one hot encoding for this. Similarly, we do one hot encoding for smoking history, and then what we created all these variable in a list. Here you can see I uh, or you can say I combined all this value in a list, and then I use model.ped for that and save that prediction uh, into this prediction. If my now I you can say initialize an empty string, that is output is equal to empty string, and if my prediction is equal to 0, then my output will be false, and if my uh, prediction is equal to 1, then output will be true. Then what I have what oh we have to use URL for, yes, for what we have to use URL. Here you can see we have to redirect our you can say when we what we have to return, we want to redirect our you can say function or page to which URL for output URL. Like if it is true, then it will redirect to this part, and if it is false, then it will redirect to this part. So what's inside this, let me explain. If we get true, then we get into this true column, and we return we what we return, we return render template return a true dot return. It means we get this HTML file. Let me We will get this page, and when we get false, we get back to this page. Let me try to run this app. For running this app, it will take some time. I'm getting an error. It is import.pickle. Just a second. What error? Good. I don't understand. Inconsistent version boarding, trying to unpickle a forward. Oh, so a few days back I updated my scikit-learn, so that's why my current version is 1.30. Uh, my current version is 1.30, but for this I need version 1.20. What can I do? Let me create a new environment for this. Let me open my Anaconda prompt, and there I create a new environment for. Mhm. Now let me create Conda. I already read admission for. You can say I already wrote the command Conda create. I want to create a what minus n new environment in environment name with Python version. This. This is creating a new Python version for me. Now hit one. For activating my Conda environment, I have to use Conda activate directives. Here we can see we are in directives. Let me change my directory to this directory, directives prediction. Put it cd is in D. It is in projects. The in projects it is in directives here. Now I have this file requirements.txt. Uh, if I use this command, and this requirement.txt has all you can say all libraries which I need to run this web app. So I will install all these libraries. Here you can see my scikit-learn version is 1.2.0. Here it is. For installing this, I have to use pip install -r requirements requirements.txt. So it will you can say install all these libraries. So this preparation. Now let me try to run my web app. For running my web app, I use this command python app.py. We do not have markup safe. What we can do? Let me do pip install. Again, try to install Flask app. It is settled. Typical content. Also try to import requests. scikit-learn with version 1.2.0. It will take some time. We can wait. We are getting error also. I think we have to use update pip also. But let's try again. Here you can see my web app is running on this host where port is 5000. Here you can see I can give here I am getting three options. Here I am getting two options. I can and here BMI that here I am former submit this button. Here you can see my web app is successfully running. If I click on this home button, I go back to this home. And for closing this web app, we can use Control plus C. We can deploy this on Amazon EC2 instance. For this, you can refer to my live stream with day 3. I will link that down below in my description. And thanks for watching.